We have now a 4.5 kilogram mass and a force of 31.5 newtons. We'll assume this is a net force. The mass has an initial velocity of 0, and we're looking at a time interval of 4.1 seconds. And we ultimately want to determine how much its kinetic energy changes during that 4.1 seconds. Well, the acceleration is 31.5 newtons over 4.5. That should be kilograms, not newtons. So make that into kilograms. Okay, so the acceleration is 31.5 newtons over 4.5 kilograms, or 7 meters per second squared, from which, using the usual procedure, our delta V is going to equal 7 meters per second squared times 4.1 seconds, 28.7 meters per second. Final velocity will be initial plus change in velocity. Initial velocity is 0, the change is 28.7 meters per second, so the final velocity will be 28.7 meters per second. Now we're trying to find the kinetic energy, but we're going to digress here for a minute. I'll just note that now that we have the final velocity and we know the mass to be 4.5 kilograms, we can easily find the kinetic energy, the 1/2 mv squared. We're going to digress here just to make a comparison. This is not really necessary to solve the problem as stated, but it's an important idea. Okay, we just proceed. Having found the final velocity, we find the average velocity. Since initial velocity is 0, we easily find the average velocity, multiply that by the delta t to find the displacement. Now we calculate our change in kinetic energy. The initial velocity was 0, so the change in kinetic energy is just going to equal the final kinetic energy. The initial kinetic energy is being 0, the only change is then equal to the final kinetic energy. And we do that by simply substituting the 4.5 kilograms for the mass, 28.7 meters per second for the velocity, and we do the calculation and we end up with 1850 joules. Now there's a side note here, and maybe we will zoom in on this a little bit so we can see clearly what the side note says. The side note simply says that, note that we calculated the final kinetic energy from the mass and the final velocity, but this is also equal to the 31.5 Newton force multiplied by the 58.8 meter displacement, or the 1850 joules of work done on the object. So if we calculate the work done on the object, if the object starts from rest, if we calculate the work done by the net force, that's going to be equal to the change in the kinetic energy. Another situation, we have a 5.9 kilogram mass, a net force acting on it of 38.35 newtons, and a time interval of 5.1 seconds. Initial velocity again 0. And we want to calculate the amount of work done on the object during this time interval. Well, the amount of work done is equal to the net force times the displacement. We don't know the displacement. We've got the net force, but we don't know the displacement. Well, displacement is equal to average velocity times delta t. So if we can find the average velocity, then we could find the displacement, and since we know the net force, that would allow us to find the work. To find the velocity, average velocity, the acceleration is just F over m, and if we simply substitute the force, the 38.35 newtons here, and the mass 5.9 kilograms here, we get the 6.5 meter per second squared acceleration, so that our change in velocity over the 5.1 second time interval, we take our acceleration, the 6.5 meters per second squared, multiplied by our time interval, 5.1 seconds, to get our change in velocity, 33.1 meters per second. Now, since initial velocity is 0, the average velocity will be the average of 0 and 33.1 meters per second, or 16.6 meters per second, so that our displacement will be the 16.6 meters per second times the 5.1 seconds, the 84.5 meters. Now that much is a fairly straightforward calculation using what we have. And then we calculate our work. Also straightforward calculation now that we know our displacement. Multiply our displacement by our 38.4 Newton force. Note I've rounded to 3 significant figures here. Since our actually I should have rounded to 2 because least number of significant figures we have is 2. In any case, we get about 3,240 joules for the work. And we can note that the 1/2 mvf squared that we get at a final velocity of 33.1 meters per second and a mass of 5.9 kilograms that we have here, if we substitute those and calculate it, we get the same thing that we got here for the work. So the final kinetic energy is equal to the work done by the net force.